In abstract algebra, an element of a ring R is called a left zero divisor if there exists a non-zero x such that x equals 0, or equivalently if the map from R to R that sends x to x is not injective. Similarly, an element of a ring is called a right zero divisor if there exists a non-zero y such that ER equals 0. This is a partial case of divisibility in rings. An element that is a left or a right zero divisor is simply called a zero divisor. An element that is both a left and a right zero divisor is called a two-sided zero divisor. If the ring is commutative, then the left and right zero divisors are the same. An element of a ring that is not a zero divisor is called regular, or a non-zero divisor. A zero divisor that is non-zero is called a non-zero zero divisor or a non-trivial zero divisor. Examples. In the ring, the residue class is a zero divisor since the only zero divisor of the ring of integers is 0. A nilpotent element of a non-zero ring is always a two-sided zero divisor. A idempotent element of a ring is always a two-sided zero divisor, since examples of zero divisors in the ring of matrices are shown here. A direct product of two or more non-zero rings always has non-zero zero divisors. For example, in R1 times R2 with each ring non-zero equals, so is a zero divisor. One-sided zero divisor. Consider the ring of matrices with an, then an, if, then is a left zero divisor if is even, since, and it is a right zero divisor if is even for similar reasons. If either of is, then it is a two-sided zero divisor. Here is another example of a ring with an element that is a zero divisor on one side only. Let be the set of all sequences of integers. Take for the ring all additive maps from 2, with pointwise addition and composition as the ring operations. Three examples of elements of this ring are the right shift, the left shift, and the projection map onto the first factor. All three of these additive maps are not 0, and the composites are both 0. So is a left zero divisor and is a right zero divisor in the ring of additive maps from 2. However, is not a right zero divisor and is not a left zero divisor. The composite is the identity. Note also that is a two-sided zero divisor since, while is not in any direction. Non-examples. The ring of integers modulo a prime number has no zero divisors other than 0. Since every non-zero element is a unit, this ring is a field. More generally, a division ring has no zero divisors except 0. A non-zero commutative ring whose only zero divisor is 0 is called an integral domain. Properties. In the ring of n by n matrices over a field, the left and right zero divisors coincide. They are precisely the singular matrices. In the ring of n by n matrices over an integral domain, the zero divisors are precisely the matrices with determinant 0. Left or right zero divisors can never be units, because if A is invertible and x equals 0, then 0 equals or minus 10 equals or minus 1 x equals x, whereas x must be non-zero. 0 is a zero divisor. There is no need for a separate convention regarding the case R equals 0, because the definition applies also in this case. If R is a ring other than the zero ring, then 0 is a zero divisor, because 0 1 equals 0 and 1 0 equals 0. If R is the zero ring, in which 0 equals 1, then 0 is not a zero divisor, because there is no non-zero element that when multiplied by 0 yields 0. Such properties are needed in order to make the following general statements true. In a commutative ring R, the set of non-zero divisors is a multiplicative set in R. The same is true of the set of non-left zero divisors and the set of non-right zero divisors in an arbitrary ring, commutative or not. In a commutative Noetherian ring R, the set of zero divisors is the union of the associated prime ideals of R. Zero divisor on a module. Let R be a commutative ring, let M be an R module, and let A be an element of R. One says that A is M regular if the multiplication by a map is injective, and that A is a zero divisor on M otherwise. The set of M regular elements is a multiplicative set in R. Specializing the definitions of M regular and zero divisor on M to the case M equals R recovers the definitions of regular and zero divisor given earlier in this article.